So today we are looking at section 10.4, the determinant of a square matrix. Remember, a square matrix means it has the same rows as it does columns. So a 2 by 2, a 3 by 3, a 4 by 4, those are all square matrices. Those are the only things you can take determinants of. So you cannot take a determinant of a 2 by 3 or a 3 by 2 or a 3 by 1 or a 5 by 7 or anything like that. It has to be a square matrix in order to find the determinant. And so we are going to be looking at determinants because determinants, along with the inverses that we just talked about in the last section, those are going to be applied in section 5. So determinants come up with Kramer's rule. So I need to make sure that you know how to handle doing a determinant. So a determinant of a 2 by 2 is where we're going to start, because also part of the method for doing a 3 by 3 or a 4 by 4 is a method called expansion by minors. And in expansion by minors, what you do is you take a 3 by 3 and you turn it into a bunch of little 2 by 2s. So in order to be able to do that, you have to know how to do a 2 by 2. And doing a 2 by 2 is fairly simple. It is basically the cross product. So you're taking this A times D, that's this part, and then you're taking the B times the C, that's this part, and you're subtracting those two products. But you do need to do them in the correct order, or you'll get the opposite of the answer that you actually want. So you have to do the AD first and then the BC next. If you get a value of 0, then that's going to be important when we get to Kramer's rule, because having a denominator of 0 could be a problem, right? So anyway, to find the determinant, for example, of this matrix here, what you'll notice is that a determinant, when we did a matrix before, it's hard to tell here, but there are square in brackets around this. The word editor that I was using doesn't show that as pronounced, but that is what the matrix looks like. So a matrix has squared in brackets around it. When you are finding the determinant, you use just bars like this that look a lot like absolute value bars. They're not. They're determinant bars, but there is a difference. So squared in brackets means that that's just a matrix. As soon as I put it in just regular bars like this, then that tells me I'm doing the determinant. So in order to do this one, I'd be taking 2 times 3 first, minus, and then I'm taking the 4 and the negative 2 and multiplying them together. It is very easy to mess this up if you're not careful. So do both products and make sure you go and write down that minus sign between them. So this comes out to be 6, and then minus, that's a negative 8. So this actually comes out to be 14. Okay, and a lot of times I'll get students who'll think that that's negative 2, because they'll go, oh, 6 and minus 8, and then they're like, that's negative 2, but they forget that it's minus a negative 8. So just be careful, because that's going to mess things up if you just make that one little minor mistake. And we know that those minor mistakes are the things that tend to mess us up on tests and quizzes. So anyway, this is just me typing it out because I had way too much time in my hands at the time I created this, apparently. All right, so here is one that I want you to try on your own. So hopefully you've had a chance to try this one. If you haven't, you're watching the video, pause the video until you've tried it. But for this one, we've got the determinant of negative 2, 3, negative 8, negative 5. Again, maybe put down your minus sign first and then do your cross products. Negative 2 times negative 5 is a positive 10. Negative 8 times 3 is a negative 24. So 10 minus a negative 24 is a positive 34. So hopefully that is what you got for your answer.
Bazinga.
That's what I have here, so good.